Hello everybody and welcome back to Stationeers. So I have had a couple of requests in Discord. You'll probably notice that I'm doing a few of these because people are asking me, and yeah, I'll do as I'm asked, if I can. I have been asked a fair few questions privately about IC, like little tips and like how do you do something? Why isn't this working? So I kind of thought I will put a like a mini playlist together covering the absolute basics of IC. I'm not an expert by any means. Like seriously, there are tons of videos out there. But I'm gonna add my side of things to that collection that's on the internet. And yeah, I will kind of go through absolute basics. Like if you have never touched IC in this game before, A, you're missing out. B, this playlist is for you. Some people think that IC is quite it's quite complicated, and some people will struggle. Everyone learns differently. People understand things in different ways. I do think that if you play Stationeers, you can play without doing IC 100%. But I do think that if you can get your head around it, even the basics, it will open the game up. That there is so much more you can do. As soon as you start dabbling, honestly, you'll never look back, and you'll be glad that you took the time to learn it. So like I said, I'm not an expert. This is aimed at people who have pretty much never touched IC and I kind of want to dip the toe in, and so yeah, here they are. And these videos are going to be relatively short. They're going to be one small concept. We're going to break it down ridiculously to the point where you're probably thinking, what was the point of making the video? But I want to make it as bog standard, easy as I can. If you know IC and you've done IC, this video, not for you. But when you are first getting into it, or you first want to get into it, there are a couple of things that you're going to need. We're going to start with like prerequisites. So for this stuff, you're going to need, as a minimum, the tier 1 electronic printer, which, to be fair, you will, before getting to this video, you should have that in place. You should also have some kind of power source in place to kind of operate this. Once you've got the tier 1 electronics printer, you're going to need cable. I'm going for heavy cable, but you don't have to use heavy cable. You can use normal cable. You're going to want an IC housing. Don't worry about that right now. You're going to want an IC editor motherboard. You're going to want an integrated circuit. And then you're going to need the computer or the laptop. Now, when you're first starting out, the computer is probably what you go to because you only need a tier 1 printer to make the computer. Whereas for the laptop, pretty positive you need the tier 2. So the laptop may be out of reach to begin with until you've got your basic alloys. But then, to be fair, in order to make the circuit and the housing, you need the alloys as well. So you should be in a position to make the laptop. Once you've got that stuff, then all you need is a concept or an idea or something that you want to code, something that you want to automate. So this video is going to be very simple. We are going to use a lever to turn on a light. Now, if you've touched the logic circuits in the game, you'll know it's doable with that. Why would you touch IC? You're right, that is doable. But this is to kind of dip your toe into the world of IC. Anything you could do with the logic circuits, you could do in IC, and you could do it better. So, long story short, let's get on with it. So, the concept that we're going to do is pretty straightforward. I have a light. And what I want to do is when I pull this lever, I want that light to come on. Okay? Really simple, but let's start. It's not what we're doing, it's how we're doing it. Understand that concept and you're already on your way. So in order for this to work, and what I'm about to say doesn't have to be like this. If you're an advanced player, you know there's other ways of doing it. But the way we're going to start is make sure that all your devices are on the same network. Later on in the game, they don't have to be, and there are ways around it if they're not. But for now, they would be on the same network. If you're not sure what this is basically an RTG. It's available in creative mode, and all that's going to do is provide power. So look, I could turn this light on, because that's providing power to it. If you're playing survival, just playing the game as you should be doing, then you would have this. You would have solar panels. You would have battery. Whatever is powering your base would replace this. So at the moment, obviously, we've got our lever. Doesn't do anything. It's just a lever, and that is what it is. We've got our light, which works, but we want these two to work together. So we're going to place the computer down, and we're going to get that connected and get it built. So if I get me some wire cutters, you'll want to connect the logic and the power on the computer. And then you're going to have a housing. Now, since the update, there are two types of housing. Realistically, it doesn't matter which one you use for this scenario. There are situations where you may want to split the logic port, because if I place this one, you see that you've got logic at the bottom, indicated by this little network symbol, and then you've got power, indicated by this little red symbol. But for what we're doing, it doesn't matter in the slightest. So I'm going to use the compact one, because both ports are on the same connection. Absolutely fine for what we're doing. We'll go through why you would use the other one in later videos. So I'm going to get the IC housing connected, and then we have our circuit. So pop it in there, and then don't forget your IC editor motherboard. You want to pop that into your computer. Okay, and there we go, we're all on. So, if you haven't touched this before, basically the housing is going to, basically houses the circuit, and the circuit has the code on it. The housing runs the code that is on the circuit. You've got the little on-off button in the top left-hand corner, and then you've got 6 pins. These pins allow you to connect to devices. So, for example, where's my screwdriver? Oh, it's there on the floor, look. Let me grab that. So, I can, for example, I can connect, and just using my left click, I can select the lever on that pin, and then we can put the light onto that pin there. You can hold C, so if I go that way and then hold C, I go back through the devices. For now, don't worry too much about this. I've got the lever connected to the pin called D0, and the pin connected, the D1 pin connected to the wall light. And very simply, we want this lever. So when we open the lever, we want that light to come on. Now, there's one other thing that I've forgotten. You are going to need, you don't have to do this, but it's easier. You want a configuration cartridge. Now, that can be printed from the electronics printer as well. And that's the tier 1. So all of this can be done with the tier 1 printer. But yeah, get yourself one of those and just slap it in your tablet. I already had one, but never mind. And then what you can do is you basically point at a device, and it will give you information about that device. While you're learning IC, I would definitely recommend trying to get this, because it will allow you to understand what a device is doing and how you're going to use that information to manipulate other items in the game. So, you're going to want to look at your Stationpedia. And basically, because we know we want a lever to operate a light, I want to look at those two things. So, for starters, let's look at light. And we're using the wall light. Down here, you've got all of your logic, options, really. So, you've got the power, you've got the lock, prefab hash. Don't worry too much about all of this for now. The only one we're interested in is on. You can click on the text, and it basically tells you there. So the current state of the device, 0 for off, 1 for on. So if you're not used to true and false logic, true in the world of coding equates to a 1. So true, 1, on, or working or whatever. 1 is yes or on, 0 is no or off. So if we look at this wall light at the moment, so it's on, it's off. If I get my configuration cartridge, you can see the on there is 0, which means false or off. If I turn the light on, you can now see the on has become 1. Okay, off, on, off, on. Straightforward. The lever has the same kind of thing. So here you can see we don't have an on, but we have an open. If I hit the lever, you can see our open is 0. If I open the lever, our open is 1. Same principle. You've got 0 for off or closed or whatever. You've got 1 for on or true or whatever. So all we need to do is we need to write the 1. So if this lever is open, because it's a 1, we want this to be 1. Its on should be 1. And that is a very simple case of just reading from this and saving to this. Now to get that working in IC. So when you click on edit for the first time, you're going to be presented with this window. If you're doing this for the first time, I highly recommend clicking the pause button, and that will pause the game for you in the background. So your days aren't moving, your gas isn't working, you're not breathing, you're not needing water, food, whatever. It allows you to take your time in here while you're figuring things out. In the top right corner, you've got access to the functions. It's a long list in here. I'm not going to scare you with this. We'll touch on quite a few of these in this playlist. Feel free to have a read through, but I'm not going to overwhelm you. X, so this gives you basically a list of variables. Again, we aren't going to go through this. Don't worry too much about this. Read it if you want to. I'm not going to overwhelm you. This button as well gives you slot variables. Again, read it if you want to. I'm not going to go through it. Basically, what we're going to do is we're going to write the code into here. Now, you have a total of 128 lines. It says 127, but you also have line 0. And that is the maximum that you can have a single chip run the code for. Or, sorry, that's the length of your code on a single chip. So, if you want to basically load from a device and save to a device, your code needs to know what those devices are. And that is what is done by the pins. So we've got a pin called D0. So we can do stuff to D0. We can do stuff to D1. But when you're reading your code, so for example, if I put D0 in here, it doesn't really mean anything to me. And like, yeah, I know that's the pin, but I don't know what device is on that pin. So there's something you can do called aliasing. And aliasing just means giving something a different name. So, for example, we can do alias. And we can alias, and let's call this the light to D0. Okay, so you see there, not the light, sorry, the lever. So let's do the lever to D0. So obviously we've got a lever on there. We can use either lever or D0 in our code. It's completely optional. You don't have to do this if you don't want to. You can just use D0 if you know what your code is. But to make it user-friendly for reading, we're going to alias. We're going to give that a name. We're going to do the same for the other pin. So we're going to alias the light to D1. If you ever need help with the code, you can hover over the yellow writing and it will tell you what it does. Now, some of this is clear, some of it isn't, which again is another reason for this video. But long story short, you can just give something a name and yeah, jobs are done. You can do stuff with registers later. We're not going to touch on that right now. Well, we're going to touch on that in a little bit, but all we're doing at the moment is we're just giving the pin a different name. So we want our code to, for example, if I open this lever, I want the light to come on. When I close it, I want it to come off, come on, come off, and I want it to always be doing that. I want that to always work. So what we need to do in our code is we need to create a section that is almost like a loop, because we need the code to be constantly checking the status of that lever. So I always start my loops with start. And if I put a colon, you'll see it goes purple. So call this whatever you want. It doesn't matter. I'm going to call this a label. And basically you can create various labels throughout your code just to either as a header for what you're doing or as a jumping to point. And we'll cover that later. Right now, we're just going to do start. We're starting our code. So the first thing we want to do is we need to figure out what the lever is doing. Like, is that lever open or is that lever closed? So we want to load from the lever. We want to take some information from that lever. So we're going to use L. If you hover over it, it loads device logic type to register by housing index value. Yeah, it's not, if you're new to it, it's not clear. All you need to know is that L means load. You are loading from a device. Now, the way this function works is we're going to load, and then you're defining, so whatever you load from it, whether it's open, close, apple, banana, whatever, I don't care. You need to first tell it where is it going to store the value. Once it's loaded it from the lever, where is it going? And you put that information in something called registers. So I could put R0. Now R0 is a register. There are a total of 16 registers starting from R0 to R15. There are some special registers which we're not going to cover right now because you don't need to worry about those. But there are 2 other ones as well. So I'm saying there's 16. Other people might say there's 18 and they would be right. But for the purpose of this video, I'm not touching on them. Just know that there are 16 registers. So what we're going to do is we're going to load into R0, and this is just a place to store information. Every time you load, you're probably going to want to put it into a register. So we're going to load into R0, and next it wants the device. Now again, for the purpose of this video, we're going to do it in a single way. This tooltip here suggests there are multiple ways of doing it, and there are, but we're going to do it from the pin. So we have lever on D0. Okay, so I can either put D0 in there if I want to, or I could put lever. It doesn't matter. Both of those are the same thing. It's just it has that is the pin. That is the name we're giving to the pin. So we're going to load into R0 from the lever, and then the last bit we need is the logic type. Now the logic type, when you're looking at it with the configuration cartridge, you can see here logic type. So all of these white text, so this lever has 7 logic types. Now as we established, the one that we want is the open. I mean, looking at this, we could also use setting as well, but we're going to use the open because I think it makes more sense in the code. So in your code, we're going to do, and this is case sensitive, we're going to do open. Can't type. With a capital O. Okay, so we are loading into our R0 register from the lever the open logic type. So at this point, when we load that, this will contain either a 0 or a 1 because that is what this lever is kicking out. If it's open, it's a 1. If it's closed, it's a 0. So we know we'll get either a 0 or 1 in there. Now what we need to do is using that 0 or 1, we need to tell the light to come on. Now again, 1 is for on, 0 is for off. So most of our work here is done for us. All we need to do is save that value to the light. And just to cover it, when you are looking at the logic type, certain logic types you can read and write to, others you can only read. So when you see read, that means load. When you see write, that means save. Or set, whatever you want to call it. So we can see that we can write to the on property. We can also read the on property. If I look at the lever, you will see that the open, we can also read and write to. So if I wanted to, I could save to this lever the open. I could automatically get it to do that. Now, I don't need to do that right now, but you could if you wanted to, because it tells you there read and write. So, how do we save to the light? Well, we load from the lever with L. So you guessed it, we S for save or S for set, whatever you want, or store. It doesn't matter. Basically, I remember it as save, but I'm sure someone will tell me I'm wrong. And the save is a little bit different to the load. So obviously, load was register, device, and then logic type. The save is device, logic type, register. This tooltip is trying to guide you. So if you're unsure, just take a look at this and try and have a think about what it's telling you. The first thing it wants to know is, what device am I saving to? Well, we're going to save to the light. So I'm going to put light in there. Next, the logic type. Again, if you search for light, the logic type is the on. And remember, it's case sensitive. So capital O-N, and it goes orange, which means it's a valid logic type. And then then this bit here, now it can be a bit confusing because it's got the R. So what that looks like is it wants a register, and that register will work. You can also put numbers in here. We don't want to. If I did a 1, then I would always be turning that light on, because remember, 1 is true, or 1 is on, or yes, or whatever the positive is. 0 would be off, false, whatever. We don't want it to always be on. We want it to only be on based on this. So all I'm going to do is I'm going to put R0 in there, because that will be a 1 or a 0 based on this line. So we are loading into R0 from the lever, the open, and then we are saving to the light, the on logic type, as whatever R0 is. Now, as you're writing your code, it's probably good practice to leave some notes. So what you can do is you can use the hash, and you can write, you can write a string in here. And this just helps you, when you come back to it later, what is my code doing? So I am loading from the lever, the open value. Or let's word it a bit better. We are loading from the lever, whether, can't spell, it is open or not. And then down here we are saving the lever value. That's not how you spell lever, is it? Well, it's a type of lever. The lever value to the light. When you are writing notes, when you start getting better at your code, keep these short, because what you'll notice down here is the size of your code. The maximum it can be is 4096 bytes. For every letter I put in here, the size of my code is increasing. Just bear that in mind. With basic code, it doesn't matter, because you're not going to hit this. But when you start getting more advanced, it's very easy to hit the maximum size. So at that point, you probably start like making your notes shorter, or you might not alias, because every letter in here is using a byte. But for now, it doesn't matter. So we're loading the lever. We're saving to the light. The last thing we want to do, so what happens is when you run code, it runs top to bottom. So at the moment, when we execute this code, it's going to start at line 0, run all the way down, all the way to the bottom, and then it's going to stop, because there's nothing down there, and that's it. In order for it to constantly be doing this, we need to create a loop. Now, the way we can do that is by jumping to other lines of code. So to jump, you guessed it, you can use the letter J. And if you hover over it, jump execution to line A. So basically, when the code gets to line 6, it will jump to whatever line we specify. So if I wanted to, I could put the number 3 in there. And what that will do is it will load from the lever, save to the light, jump to line 3. It'll go up to here, which is here, and then it will run the code again, because it always wants to go down. So it'll just keep doing this and over again, and that is basically a loop. Even though you can do this, I strongly suggest you don't. Instead, use the label, because I can also jump to start. The reason for this is because if you put the number 3 in there, but then later you decide to change something, so if I just had to put a note in here, This jump is going to jump to line 3. Now, in this specific situation, it won't matter because it will still work. But when you get advanced coding, you may be triggering lines of code that you don't want to. So it's always good practice to have a label and then jump to the label. So no matter what I do here, it will always jump to start. It's always going to only execute these 4 lines. So let's tidy this up. And that is pretty much it. That is the absolute basic of IC. You load from device 1 or device A or whatever you want, and you save to device 2 or B or whatever you want. In this case, we're loading from the lever, we're saving to the light. Let's put it into practice. Let's see if it works. So once we're finished, once we're happy, we're going to click confirm. And then what you're going to do, if you're using the computer, you're going to make sure that you have the correct IC housing selected up here. Now, we only have 1, so it's not an issue. However, if you have 2, you've got to be very careful that you do not save the code to the wrong one. Because if I have another IC housing on here that's doing something else, if I export, I will override that one and lose all my code. So, good practice is to label your housings. So what we'll call this is light housing ep1. Click confirm. Now you'll see that we've got light episode 1 up here. If I had another housing, obviously I would give it a different name. You don't have that issue. So we've got our code and we know which housing we're going to get to the right one. So all I need to do is click export. Now, if I look at my circuit, you will now see it says 168 bytes. I have code on that circuit. And that code the size should match this, which it does, 168. But I know my code is on here. I've already set my pins. If I hadn't set my pins, then I would change those. Whenever you're changing pins, always make sure the housing is turned off. Because if you leave it on while changing a pin, your code will still be running. And if you've got code that is saving something to a device and you're cycling through the pins, you could potentially be saving information to the devices that you don't want to. So, mental note, if changing a pin, turn off the housing. So, at the moment, this light, I can operate this manually. This doesn't do anything because the housing is off. I'm going to open the lever. And what should happen is when I turn the housing on, that light should come on. There we go. Because that lever has got a state of 1, my light is on. For the moment of truth, there we go. We've basically created a light switch. Very basic, very easy, but this is the core concept of what your code is. You load from a device, and then you either save to another device, or you do something with the value you loaded, and then you would save it to a device. Okay? And that's it. The core concept, done. Easy. If you've got this far, well done. You've dipped your toe into IC and you've come out the other side happy, hopefully. Hopefully that makes sense. Hopefully that is not patronizing, but I'm trying to kind of baby steps. I don't want to scare people. So let's just start with this. If you can get the core concept of this done and you understand what is happening in here, you can understand that we've aliased, we've given something another name. We've created a label which we can jump to. So this is effectively creating a loop. We've had a look at registers. We can load information from a device into a register, and then we can save to another device that registers value. Obviously a very easy example, but the idea is that you load and save to devices. Ignore this. You could have a massive, I don't know, power plant or gas, or you could read pressure from a tank and do something else. There's loads you could do. This is just to get you started. And we're going to leave it there. These are very short videos, to the point, and hopefully each video will become more and more complex as we get on. And who knows what the hell we'll end up with at the end. Maybe we'll end up all the way over there on the mountain. Who knows? But yeah, so I'll call it there. Thank you for watching. and I will see you in the next one. Take care. Bye.